This is their microservices map that they presented at a conference. And I wasn't there, so I don't know whether these big dots are like lots of microservices compared to the smaller dots. But whatever you look at this, there's thousands of microservices involved there. They only started their microservices journey in 2016. So in 3 years, they've gone from 0 to thousands of microservices. And when you build this code in this disaggregated world, you have to worry about all kinds of things that you don't have to worry about when you build local code. So you have to worry about what happens if you're doing distributed work. How do you roll back things that didn't work? Because in a local machine, you can just say it's all happens or nothing happens. When you start distributing it, you have to worry about distributed transactions. There's a pattern called a circuit breaker. Has anyone come across a circuit breaker? A couple of you. So a circuit breaker is when a system goes down in a distributed environment. What typically happens is when it comes back up, there's all this workload waiting for it. And it's maybe a scalable system, and it starts with one instance and it wants to scale up nicely to the number to handle the balance. But what actually happens is all this workload hits it again and it goes straight down again. So you need this concept of a circuit breaker to try and stop it from just failing over when it comes back up again and give it time to recover. There's obviously things like payload handling, network types like JSON, XML, gRPC. There's eventing, and asynchronous communications are very, very important. Of course, there's security. So we need to worry about protocols like OAuth, token systems like JWT, and so forth. And this whole list of things typically are complex to deal with. And so you're writing in Python or even a new language like Go or Rust, and the first thing you have to do is spend a lot of time finding all the libraries and choosing which library you're going to do to use this. So Ballerina was designed to try and make that much simpler and to build in a lot of these concepts. And it's a compiled, type-safe concurrent language. So that's a very important aspect of this, is it's trying to build safe, secure applications, and I'll talk a lot more about that. So rather than talk anymore, I'm just going to start, and I'm going to start by installing it. Now, I have already downloaded that installer, just in case the network wasn't very good. And I'm just going to install it. And I'll talk about the implementation and the other aspects of the language a little bit later, but I thought it'd be just fun to sort of write hello world and get started. And I have an empty directory here. There we go. And I've got VS Code. Any VS Code users here? Good. Any IntelliJ users? So that's most of you. So IntelliJ also has a plugin, and VS Code both have plugins for this. So that helps a lot, especially because it's a type-safe language. The type checking and validation comes through in the editor. And just to be truly authentic, I have not installed the Ballerina plugin. I'm just going to go to the marketplace and install it and start from there. So if you want to try the same thing, you do the same sort of stuff. And that looks good. So I'm not going to write a hello world that prints something out. I'm going to write a network hello world. So I'm going to call it over HTTP. It's going to respond with hello world. So I'm going to start by importing HTTP package from the standard library. And I'm going to create a service. Now, most languages, you create a main, don't you? And you can create a main in Ballerina. But fundamentally, one of the main things that you want to do in a network language is create a listener. And so we have services, and you probably didn't have a chance to see that, but here are some of the services. You can create gRPC, HTTP, WebSocket, WebSub. You can also listen on Rabbit, NATS, if you know that, ActiveMQ, all kinds of network protocols you can create a listener on, and it's extensible. And I'm going to call this the hello service. And I want to say hi. And I'm just very simply going to possibly handle an error and return to the caller hello world. well, why don't we go hello Budapest? And is this big enough that you can see? Do you need me to maybe just enlarge it one more like that? And I'm going to build and that's created a executable, and I'm going to run that executable. And it's automatically creating a path based on that service and method resource name that I used. And there we go. So very, very simple code for a Hello World network. Now, of course, we probably want to do something more useful than just respond Hello World. So the thing I think we'd like to do first is to pass some name equals Paul, and probably we want to pass it as a JSON, don't we? That's the most likely starting point for a network service, is JSON over HTTP. So that's the kind of message I want to send. So I'm going to show you some data binding in Ballerina. So we can actually bind that very, very simply into an object, which we want to then read data from. And I'm going to create a record type. So Ballerina is object-oriented. It has objects. But typically, when you're dealing with network stuff, you don't really want to do distributed objects. You know, we tried that with Corba, DCOM, spent a lot of time, J2E, all these things. It turns out to be a lot of bother without much value. So typically, you just want a record, a structure. You just want to say, I'm sending some structure over the wire. And so I'm going to call this the input structure. And I'm just going to say, let's say, string name and int age. And I want to bind this to the thing. So what I'm going to say is, I'm going to annotate this method with a few different things, and I can actually show you all the things they are. So I can annotate it to say it consumes application JSON, and I can annotate the body to say I want an input variable, and I can annotate it with methods to say I only want it to accept post. There we go. And so now I can basically just bind that input here and say I've got this input, it's one of those objects I created, and that's what I'm expecting to get in. And I can access that very easily. So I can say string name equals input.name, and I can do hello plus name. Uh-oh. I seem to have an error here. Now, the error is saying that a tainted value has been passed here. This is really interesting. So one of the big problems in network systems is that you get injection attacks. So somebody is passing over some data in a network packet, and it turns out it's somehow causing a misbehavior. So a lot of languages have these taint checkers that you can download and apply. Ballerina is the first language we know of that has said, well, we're a network language, we want to be secure, so we're going to make sure that the taint checking happens within the language from day one. So what do I need to do? I need to make sure that that data isn't tainted. So what I could do is I could replace all, and I can say a little regex. And so I want to get rid of anything that's not A to Z. And then having done that, I can mark it as untainted. And now hopefully I can run this again. And now I also said age, so age equals 50. Let's try that. And did I get that right? Okay. So I've done something wrong here. So I forgot to recompile. I don't have to recompile. I can just run the .bal file and it will compile and run it. It's a slightly slower, but obviously works fine. So now I can try that. And now I've got an error, which is that oh dear, I sent it a string for the int, but I defined in my record, I defined it was an integer. So this is another nice thing. I've instantly got some data binding and data validation with almost no effort. So all I have to do there is I want to correct that. So HTTPIE does it like that. And now if you look at what I sent over, I sent it as an int and it parsed it correctly. So we very simply created a program, but let's also return a JSON, because that's obviously the next thing I want to do. Is I don't want to just return text. And also, by the way, just notice I sent back a string and the content type is text plain. It's going to automatically, when I send a JSON back, it's also automatically going to change that. So one of the nice things about Ballerina is JSON is a first-class type. You don't need to go find a JSON library. It's built in. So I can say my JSON.js, and I can literally just do name value like this. And I'm going to say hello, and I'm going to pass that name. And now I'm going to go and respond with that JS. Rerun it. Oh, not quite up yet. Still compiling, give it a second. There we go. And so now, as you can see, it's returned a JSON and it's set the content type correctly based on that field. So very, very quickly, we've created a JSON service. We're reading JSON, we're sending back JSON. And also, I think what's really nice here is the language is very consistent with what we're doing. I'm hoping that everyone here can understand what's going on here very easily, because the language is written with this kind of logic in mind. But I want to do something a little more interesting than just return a JSON. So what I would like to do is to now call a remote service. So I'm going to call GitHub, and I'm going to use this to create an issue on a GitHub repo. And so the first thing I want to do is to see if there's a package that supports GitHub. And we have some package management built in. There's a package server called central.ballerina.io, and you can go and search it, but also you can go here. There's a various set of packages, and I happen to know this one will do what I need. So I'm going to go and pull WSO2/GitHub. And it's called GitHub 4 because there's a v3 API and a v4 API. v4 is a GraphQL-based API. And of course, you could just create, so Ballerina has very good HTTP client built into it, so we could just create a GraphQL query. But what this package is doing is wrapping all that up in a type-safe environment. So now I need to import that GitHub. And doesn't like it. That's not a good sign. Nothing like a live demo to put you in the spot. Oh, because it's GitHub 4. There we go. And I'm going to declare a GitHub client. Call it GH. And this is an object, and I'm going to show you this details in a minute. Do you see it says endpoint above that in VS Code? So endpoints are well-defined concepts. So listeners and endpoints are core parts of the language. They're first-class parts of the language. And I'm going to explain what the impact of that is in a minute when I explain how we're going to call that. But I'm just going to cheat a little bit and pull up a little snippet of code. The GitHub client config is slightly verbose, so I'm just going to cut and paste that in there. And I need a curly brace there. And do I have enough curly braces? Maybe I should just cut and paste the whole thing. Let me just cheat even more here. And I'm not going to put my GitHub token up here in front of you all. I'm sure you're all very trustworthy. But nonetheless, this is being streamed live on the internet. I don't think that's a very clever idea. So I'm going to read it from a config file. I obviously just need to import the config helper there. Now this config getter string is going to look at first in the environment variables and then in a config file. So you can pass it either way. I should have that in my environment, so hopefully this will all work. And the reason why this is slightly verbose is because that's all a predefined OAuth 2 set of code in Ballerina. So Ballerina knows about OAuth 2. OAuth 2 is slightly complex. It has various different token models. So we've got that. So now what I want to do is let's change this input to be something more useful. So I'm going to create a title for the issue and the content. And I'm just going to get rid of that and all that. Let's just clear all that out. And what I want to do now is to call the GitHub and create an issue. And I'm going to be lazy and hard code my username and repository name here. And we're going to have input dot title and sorry. And I don't really want these, so I'm just going to put empty labels and assignees for the moment. Now, this is strongly typed. I don't know if we can read that. Basically, one of the other things that we wanted to do in Ballerina is to make sure that when you get a response back from a function, you deal with it. So you have to deal with the assignment. Now, there is a bit of a cheat. You can go underscore and say, I'm deliberately ignoring it. I'm still getting an error here because that won't deal with errors. That cheat says I can throw away the response, but I can't throw away errors. Now, Ballerina's errors are built in, and I'm going to explain how it works in a second, because it's all based on the type system. So it's quite a nice way of dealing with errors. And the philosophy is that errors are expected in distributed systems. So when Java was built, we had this idea of an exception. An exception was there to deal with the unexpected. Because when you're building, back in 1994 when Java 0.9 came out, everything was built in local systems, and errors should be unusual in those local systems. And exception handling is not very efficient. It's not very, and it's not very clean. So, but we believe that errors are the norm in a distributed system. So we want you to deal with errors, and you can still do something a bit like a runtime exception. You could do a panic in Ballerina, but that should be for the really unusual thing, like I've run out of memory, I'm going to panic. But if I just get an error back from calling GitHub, that's day-to-day business as usual. Now, there's two ways I can do this. I can say I'm either getting... So this is where I'm going to explain the type system. So what I'm really getting back from here is a GitHub issue or an error. And Has anyone used a language with a union type system before? Okay, a couple of you. So it's basically saying this object can be of type A or of type B. And so it's either the thing I want, which is the issue, or it's an error. Now, that seems very simple, and you might think, well, what's great about that? The first thing that's great about this is it represents very clearly what happens on a network. So in a network, you often call, and maybe you're expecting a JSON back from an endpoint, but there's a proxy in the middle, and the proxy sometimes returns the text instead of a JSON, or sometimes returns an XML. So you are dealing with a set of types. Now, if you were in a normal OO language like Java, what do then? You create some monster wrapper object that says, well, it could be an XML, or it could be a issue, or it could be this, and you wrap up everything in objects, and you end up with all these objects that you don't really need. They're just there to deal with all these weird cases. So this is a very nice, simple syntax to do that. And then I can just do, if response is an error, and I can handle it that way. So that's very simple. There's another way I can handle it. I can basically say that this whole method returns an error, and that error question mark is shorthand for saying it either returns an error or returns nothing. So it optionally returns an error. And now I can just use a bit of syntactic sugar that says check. And what check does is it just returns the error immediately if it's an error, and then the method calling this function will have to deal with it. Now, the method calling this function is the thing that's returning the HTTP back to you, so that will send back the error to HTTP. So now I have a response, and I can code up my JSON using some information from that response. And let's say the ID is the response.id. So we're going to have some kind of ID come back from GitHub. So hopefully, if I run that now, I forgot to do my taint checking. So I'm just going to cheat and taint there without that. So now I need to pass over the title of the issue, which is from Budapest, and the content is come up with some better examples. Let's just have a look at that. And it somehow got an ID from somewhere, so I'm hoping, fingers crossed, that we've successfully called this, and let's just refresh my issues. And there's my issue from Budapest, opened 14 seconds ago. So I hope you think that that's pretty quick. I know I've been talking quite a bit, but the actual time I spent coding was probably about 5 minutes to create a JSON input, call GitHub, respond. And one thing I think is really nice about Ballerina is that because it was designed with these things in mind, the semantics very much come from the way we deal with these kind of things. So if I go back to my presentation, so here's the sort of hello world. We did a get, we got back hello world. We did some annotations to say it needed to consume JSON. It needed to get a body message. So now we're posting. And then this is an example of tweeting, but actually I'm calling GitHub. I'm going to show you Twitter in a second. So when we're doing kind of projects like this, my go-to is I always end up drawing these sequence diagrams, especially if it gets slightly complex. Obviously, this is pretty simple. Does anyone else like sequence diagrams? Yeah, I love them. It's the only bit of UML I've ever used, really. I'm not a big UML fan, but the sequence diagrams I love. There's a really nice thing called web sequence diagrams. Anyone use that? Instead of drawing them physically, you type text and it draws them for you, and it lays them out nicely. And that was one of the inspirations for Ballerina, because we used this semantics of sequence diagrams as the semantics of the language. So that's really where the semantics come from. And as a result, every Ballerina program is visible as a diagram. So here's a sequence, here is the sequence diagram for that program I've just written. And that was generated from the code. This was not a picture I drew earlier. This was literally generated right now from that code, which I think is really awesome, because this is actually, showing me, is this really what I expect to happen? This is what I wanted, isn't it? I'm making an input, I'm creating an issue on GitHub, I'm getting a response back. For some reason, it's missing the line back. There seems to be a bug there. I don't know why, but it's still 0.991, so I think we can afford tiny bugs here and there. Does anybody like graphical editing? No, me neither. But there are some people who do. And so it is actually possible to go and edit this graphically and go and create stuff here and do, for each loops and stuff. I'm not a huge fan of that myself, but what you can see is that that's actually going and creating the code. So if you do a graphical thing, you still end up with the .bal file. You don't end up with anything else. So I'm not a big fan of that. I am, however, a big fan of being able to see my code in this way. I think it's really useful. I think it's really useful for doing code reviews, and also for going and talking to the architects and the other people in the team to say, is this really what we're aiming for? So I said we wanted to add some Twitter. Let's just do that quickly, because hopefully it won't take long. So firstly, I need to pull the Twitter connector. Let's see, there we go. And I'm going to import that. And I need another endpoint here. I need a Twitter client. And I'm going to do my little cut and paste trick again. Save you seeing all my secrets. And now I can go, I've got that, and now I can basically do a tweet and tweet some status, and I'm just going to go created issue plus. And I'm going to just do the same. And now I can add in the Twitter ID here. So we've got a Twitter ID as well. And nope. Hopefully that's going to work. And now we have a Twitter ID, so if I go and look at my tweets, and there we go. So I've instantly created, a reasonably powerful app here that's now, let me show you the sequence diagram so you can see exactly what's happening. It's calling GitHub, creating an issue, getting the data from the issue, tweeting some of that information, getting the tweet response, creating a JSON, and sending it back. So I'm pretty pleased with that. I think that's, a productive little app I've built in a very short period of time. Now, I said earlier this is cloud native. A lot of people would associate that with Docker and Kubernetes. So now I want to deploy my app into Docker or Kubernetes. And again, that's really simple. So I can basically annotate this with a Docker config, and I can say, you know, here's the name of this service, and so now let's go and see what happens when I build that. So it's now got something new. It's basically saying I'm dealing with the Docker, and it says if you want to now run this, copy this command. So I'm now going to do that. So effectively what that's done is create a Docker file, build the Docker file and put it in my local Docker repository. And now hopefully if I come over here, what's going on with this window? I'm going to just, something funny is happening there. Let's just go back. I don't know what is going on with this window. Something funny is happening. Let me just... This is really annoying. I'm just going to quit my there and just go back into it because I think something's happened to my command window there. And I'm going to do that again. Hopefully that's all running on 8080. Ah, I have some connector error. What this looks like is that my Docker networking is not allowing me to call out to GitHub from my local Docker. That's what I'm guessing. So rather than try and debug that right now, I'm going to show you it in Kubernetes, and hopefully it'll work better in Kubernetes. So firstly, let's just kill that Docker RM. Let's just okay, so that's good. So let's bring down here. So instead of doing the Docker, let's import Kubernetes instead. Now, the Kubernetes is going to be slightly more complex, so you're going to have to give me a moment here. So the first thing is, I really want to, at the moment, I'm just declaring this listener in line here. That's where it's listening on port 8080. But I actually want to declare it properly because I need to annotate it with a bit of Kubernetes gubbins to make it work. So I'm going to get rid of that. And so I need to basically say that's a Kubernetes service. So if you know Kubernetes, the service is a network listener. So that's the equivalent of our listener. So I'm going to annotate this with a listener, and I basically say I want it to be a node port. So it could be a load balancer or a cluster IP, but a node port is the easiest way in my local Docker-based thing. And then the other thing I want to do is to annotate the actual service with a Kubernetes deployment. And I basically want to give it an image name, and I'm going to call it Budapest K8S. And I'm going to give it a name, which is my Budapest. Now, there's one more thing that's going to go wrong if I don't do this right, which is that I need those secrets that I have for GitHub and Twitter to go across. I have to have my secrets in the Kubernetes environment, otherwise it's going to just give me an authentication error. So in Kubernetes, that's something called a config map. And I can basically say, I have a file called twitter.toml that has those secrets in it, and annotate that function so it's going to pass those over as a config map. So now, hopefully, if I build this again, so this time it's created still a Docker image, but it's also created a Kubernetes service, a config map, a deployment, and it's even created a Helm chart for me. Anyone use Helm? Okay. So, and if I do, so I can either use Helm or I can just do a kubectl apply. Let me just copy that for a second. But if I do a tree, you can see it's basically created all the YAML for the Helm chart. It's created the YAML for deployment. It's created the Docker file. It's all there. And if I do Docker images and grep Budapest, you'll see here's that Budapest K8s 41 seconds ago in my Docker file. And let me just show you I have nothing running in kube control so far, hopefully. So there we go. So basically I'm running Kubernetes in Docker for desktop, which makes it really easy because it shares the same Docker repo, and got nothing running, and I'm just going to kubectl apply, and now there it is running. So now it's running on port, so this node port is on port 31027. So hopefully we'll do better than we did with the last one. Let's go and change this to 31027. And there we go. So that's now deployed in Kubernetes, running in my local Kubernetes. And let's go have a look at the Twitter. There's the latest tweet, new issue created. And you can see, hopefully, that we've got several issues from Budapest now, one created 20 seconds ago. So, you know, I think this is pretty nice, because if I just look at, I'm not going to show you the whole of the Kubernetes YAML because it's got my secrets in there, but it's basically created all the Kubernetes YAML I need, created the Docker files, installed it. So I think this, from a productivity point of view, you know, here I have 65 lines of code. It's generated about 125 lines of Kubernetes YAML. It's generated my Docker file. It's done all that GitHub, Twitter stuff. And what's more is, you know, it's highly understandable what this code is. It's really clear. One of the things I should have mentioned earlier that no one's picked up on, sometimes people go, hey, Paul, what are you doing here? If you look over here, when I'm accessing these records or objects, locally, I'm just using a dot. But you'll see that syntax up there of an arrow when I'm calling the GitHub and the Twitter constructs. And that's because these are network calls. So every time I do a network call, it's actually visible in the code. Now, it's also visible in that sequence diagram, but it's visible in the code that I'm making a remote call here. And this has kind of two things. The first one is, obviously, it's just a reminder to the programmer that I'm not doing something local and that I'm going to need to be aware of all the potential problems. But it also indicates a different behavior under the covers. So, any Node.js programmers here? I've done a lot of Node programming. And in Node, if we were doing this, we would basically do an asynchronous invocation, wouldn't we? We'd call this and we'd asynchronously wait. If you did this in Java, you'd basically be blocking the thread that this comes in on. So the request would come in, maybe it's taking 500 milliseconds to call GitHub, another 500 milliseconds to call Twitter, that thread is going to be blocked for 1 second for every incoming request. If I have 100 threads and 100 concurrent, then I can only handle 100 concurrent requests a second because I'm blocking those threads. So Ballerina by default does asynchronous invocation, but you don't have to do anything clever. So you don't need to write any special async start await type code. You don't need to write any callback handlers to do this. It's basically doing a continuation. So what that means is that it's probably easier to show you on the sequence diagram. This is not a thread. This is what we call a strand. This worker has a strand associated with it. And a strand is kind of like an ultra lightweight thread. And what happens is while we're waiting for that response from GitHub, we are blocking that strand, but we've given up the thread it was on. So the thread it's on is now dealing with other work. We basically save the state of that strand, and then when that response comes back, there's something called a reactor that reacts to that incoming request, associates it with the strand, resurrects the strand, and then it carries on. So this is another aspect where the language is really built around network types and network interactions, because that in other languages is quite hard to deal with. The first time I wrote code to do this was about 14 years ago, and we needed all sorts of weird and early bits of Java code, Reactor code, non-blocking HTTP libraries. It was a nightmare. We spent basically 6 months just getting this to be stable. And this is just built straight into the language. So I think that's another really nice aspect. And that also comes through. So I'll talk a bit more about concurrency in a minute. So let me sort of have a look at the where we are. So I've showed you the annotations. I showed you some simple transformation in and out of JSON and some data binding. I showed you the fact that it's inherently async I/O. So whenever I call out to a remote endpoint, I'm not blocking. I'm basically pausing that strand and then resurrecting it when the work comes back. I showed you the fact it's based on sequence diagrams. We did the Docker and Kubernetes. Any Istio users here? Excellent. Are you fully up with the Istio YAML config? You're doing well. I frankly am not. It's pretty. That Kubernetes YAML's hard. The Istio YAML is also pretty complex. We just have 2 annotations you can add in, which basically say, I want this to be an Istio virtual service, and here's a gateway. And then we generate all that YAML for you. So again, very nice invocation. Some of the things that Istio does, I talked about circuit breakers and load balancing earlier. Those are some of the things Istio does. If you're just using Ballerina, we have a circuit breaker and a load balancer built into all our clients. So I could, if I go back, if you look at my client config here for Twitter, I can basically add in an HTTP client config which will make it do load balancing and circuit breaking. However, obviously, that's not the normal situation. The normal situation is you're not just writing Ballerina, you're using Ballerina to glue together lots of other stuff, and so that's where you're more likely to use a service mesh like Istio or Console. And so we have some built-in support. We are also looking at adding Console and Linkerd support to this, but Istio seemed the most popular, so that's the one we started with. Another obvious place where this might be useful is if you want to write serverless stuff. So this is a AWS Lambda picture, which basically says you're building some kind of function code that's deployed in AWS Lambda, and it just gets invoked when there's a request. You only pay for every invocation. Similarly, we have some really nice Annotations, you just need to annotate it, say this is an AWS Lambda function, and it will generate all the right stuff and build this into AWS Lambda. So that's another nice deployment option. It's not just AWS Lambda. We also have support in Kubeless, in OpenWhisk, IBM's serverless environment. I can't remember the name of their cloud serverless environment has support for Ballerina in it. So we're trying to add support for as many serverless environments as possible. So I talked about the type system briefly. We basically have some very few simple types. So the double parentheses is our equivalent of null or nil. Boolean, int, float, decimal, and string. Now, none of these things can be nil by default. So, for example, if you declare a string, it's not like Java where it can be a null or a string. It has to be a string unless you say it's an optional. You can say this is an optional string, and then it can be null. So let me just show you some of that. Let me just start a brand new file and call it types.val. And we'll have a simple main, and I can say string s equals hello. Or I can basically say string s question mark equals, string question mark equals hello, and that's saying it's optionally not valid. So that's actually equivalent to saying it's a string or a null, s. And it could be hello or null. So, and it's going to say you can't redeclare it. So there we go. So those are equivalent. There are some useful helpers. So one of the problems with nulls, of course, is that you get errors when you try and reference them. So if I have a record and it might be null or an error, I can basically say record.a with a that's an exclamation mark if you can't see it. That's called nil lifting or error lifting. So that basically will return an error or the value if the R is null or an error. So there's some useful facilities in there. Then we have some structured types. So we have tuples, arrays, maps, records, tables, and XML. And you notice I didn't put JSON in there. So JSON is just a union. So JSON is a union of a string, an array, a int, or another JSON. I probably missed out something, but you get the rough idea. Tables are basically mapping onto things like SQL databases or in-memory tables. And we also use these for stream processing. So we have an experimental stream processing feature which can do real-time queries on events. And it represents the set of events as a table. So I'm not going to go into the whole SQL and database access. That's kind of more, it's all there. You can build fully, full RESTful services. But really what I wanted to get at today was how you use Ballerina to integrate different systems. Any XML people here? Sort of. So XML is not so much an important thing here, but it is very nice in Ballerina because basically, have I got the right syntax here? I probably just got the syntax slightly wrong. Hold on a second. Let's input. Let me just go and cheat. So if you want to learn Ballerina, this is definitely the place to go. It's a set of tools called Ballerina by Example, and it shows you loads and loads of examples. And as you can see, I just got the syntax slightly wrong. I basically want to say the word XML there. Now, there's a few things that are quite nice here. So I can embed variables as using curly braces. I can template it. But also, just watch this. Although this looks like it's just a string, it's not. We actually understand the XML inherently. So the fact that you've put in this string and it doesn't finish, the tag doesn't finish properly, is spotted by the type checker at compile time, which means that the type checker that's built into VS Code spots it. You instantly get rid of that horrible spelling error in half a massive page of XML. So if you are, for instance, if you do want to create, quite a lot of people I know have used this to take an existing ghastly, horrible XML service that's quite hard to deal with and make it into a nice JSON service. You can basically pull up your SOAP UI or just cut and paste the XML in here, do the same thing I said of, define a nice JSON type using a record that we did earlier, and then I can embed bits of that JSON into the XML, and I can also extract the XML responses back from the service. So writing a JSON to XML service is literally about 10 minutes work to take some perhaps SOAP service and wrap it as a JSON service really, really easily. Let me just go back to the types. So obviously you've seen a lot of errors. Functions are types, so you can do lambdas and all of that kind of stuff. I haven't yet talked about futures and concurrency. I'll show you that in a second. So objects are just records with additional behavior. And we do, it's a kind of what you might call a weak OO language. So the objects allow you to have behavior. So for example, that Twitter connector is really an object, but we don't do things like multiple inheritance and so forth. It's a simpler OO model than Java or Smalltalk or one of those OO languages. And I think the aim of this language in that regard is to be pragmatic. The fact is that, especially when you're building these kind of services that I was showing you, where I'm calling multiple network services, the OO nature is not that helpful. It's useful for somebody building the connectors. It's not really that valuable to somebody who just wants to write a simple service. And so doing that, making you do objects without needing to, we felt was unnecessary. I mentioned the experimental streaming support. This is really cool. You can basically take a set of events coming in, say multiple HTTP posts, or you're listening to a Kafka queue with a connector or Rabbit topic, and we can do long-running analysis of those stream events. So we can basically say, what's the average temperature over the last hour? Is it different to the average over the last day? It looks like your server room is heating up too much. We need to do something about it. So now we're going to send a tweet to your sysadmin or an email to your sysadmin saying there's a problem in the server room. And type desk is basically the type of a type. It's a description of a type. And then there's these unions, which we've shown you already. Optional I've talked about. JSON, which is, as I said, is just a union of other stuff. Bytes, obviously you need to be able to deal with bytes if you want to write a low-level network protocol. Any data is basically saying anything apart from an error. And any is saying that this can be any data. It's basically a sort of a master. And one of the things I didn't show you before, but of course I also did quite a lot of stuff with var. You might have seen me using var. So unlike Python, var does type inference. So if I say var x equals s, and I try and do s dot, so here there's a good example. It knows by default that s is a string, and I could, sorry, I should have done x there. it knows that X is a string because it's inferred it from the fact that it's inherited from type S. So I don't have to declare types, but when I don't do it, yeah, this is gonna you get my idea. I don't need that. But when I don't declare the type safety still happens. So it still knows that X is a string and I can't do int type things with it. So the union types, I think I explained quite nicely. And, you know, this is particularly used mainly for error handling, where we basically say this is an object or an error. But also in those scenarios where, you know, this could be a JSON or it could be a simple string, for example, when I'm getting a response back. I showed you the XML. Oh, I forgot floats when I was talking about it. So a JSON is just a union of null, int, float, string, a map of other JSONs or an array of JSONs. So the concurrency model is similar-ish to Go. So there are these ideas that there are workers, and the workers communicate via lightweight internal message channel. And so this is kind of very similar if you know some maths called CSP, communicating sequential processes. It has that same similar model. And these communication channels can be either asynchronous or synchronous. So let me just show you this in some code. So I can say I have worker W1, and it's going to send I forgot to mention we have tuples as well. So it's going to send hello, comma 1 to W2, and then it's going to wait for a response. A string, yes, of course. W2. And then we need a worker W2, which is going to... Now, this is kind of cool, isn't it? So it's telling me that there's a deadlock here. So the model and the type checker is validating some aspects of this concurrency, and it's actually noticed that this is not going to move on because these interactions are incomplete, and therefore the workers are going to get stuck. So hopefully I can fix that by saying, here's my A, comma B, which I get from W1, and then I send thanks back to W1. Why am I still having a problem here? Should have thought that would work now. Let me just go look at my example. So, something is not nice here. Worker of W1 sends that to W2, waits for string back from W2, gets that. Let's just go string, int. Okay, I think I had my types wrong. So now let's just add a bit of prints in here so we can see if it's working. And Let's do Ballerina. So there we go. Worker 1 sent hello 1 to worker 2, which printed it out. Worker 2 sent thanks back to worker 1, which printed it out. And once again, we can see that sequence diagram here. There's a default worker, which is associated with that main method, which then starts worker 1. Worker 1 communicates with worker 2. Worker 2 communicates with worker 1. And then they wait and complete. So that's one form of concurrency. Another simple form of concurrency is that I can define a function, hello, that returns a string and return hello. And I can also do a future. So this is going to say there's a future string f, which is, and I get this by starting hello. I'm going to close that down for a minute. And then I can do, let's make it slightly interesting and say sleep. So let's just sleep for 1,000 milliseconds before we return. And then we can say if f is done, string result equals wait f. So, and let's just be first. Let's be clear first. And then we can just do that again down here. So what I want to do here is to say else. So I want to say, okay, I'm going to start this off, check if it's done. If it's not done, I'm going to say it's not done, and then I'm actually going to wait for it to finish and then carry on. So let's just comment that out first and run types.bal. And this time it worked instantly because I didn't wait. There was no delay, so it had completed already. Let's make it wait now, and seems like the train is running, and then this time it's not done, and now I wait for it to finish and it's done. So these are very similar to async await in JavaScript. You can also test if the future is cancelled, and you can cancel it if not. And it turns out, go on. So wait is how you get the result back from the future, even if you know it's done. It's performing two functions. It's waiting, and it's getting the result out of the future. Does that make sense? Good question. So that's workers and futures. So that's another useful thing. Obviously, if you're building these kind of asynchronous distributed systems, very common thing you might want to do is, it was too complex for this session, but obviously it'd be nice to have maybe sent the tweet and the GitHub issue in parallel. Now, in this case, I couldn't do that because I wanted to put some data from the GitHub issue into the tweet, but you could see certainly lots of network examples where you want to concurrently get a request in, start off 5 different things and have them run in parallel rather than be sequential. And that's all very easy. So wait is a blocking instruction. So if you don't want to block, you can basically question, is this done? Oh no. So again, wait is not blocking the thread, it's blocking the strand. Yes. So, and similarly, this runtime sleep is not blocking the thread, it's just blocking the strand. So if in Java, when you do sleep, you block that thread and nothing else is going to happen, and there's a limited number of them. When you do it in Ballerina, it's just wait, you know, it's going to get resurrected when that sleep is over. So I'm not going to demonstrate observability, but obviously a big aspect of building these systems is that it's very hard to see what's going on, especially when you have multiple network connections. And the big advance in this area over the last few years has been systems like Jaeger and Zipkin and the open tracing standard. So, do anyone use Jaeger or Zipkin? No? So really useful tools. Basically what this is showing is a distributed set of queries. This is actually showing you within a single system, but you can also see it across systems. And this is done simply by just configuring, basically tell the Ballerina runtime with a config statement, this is where my Jaeger server is, and it will automatically send all that tracing data to Jaeger so you get these pictures. So no coding, nothing required to get that picture out of your Ballerina system. Similarly, if you want, you're building a server here now, and you want to know what is it doing, how many errors a second is it handling, what request rate is it doing, and so forth. Again, you can do a single config, and it will expose a Prometheus port. So Prometheus works the other way. Prometheus is a monitoring tool that basically calls into Ballerina to ask for it. So Zipkin works by push, Prometheus works by pull. So this exposes, you can basically enable it and it will expose a Prometheus port on that server, and Prometheus will come and grab all this kind of monitoring data. Anyone use Prometheus? Ah, there we go, a higher proportion. And there's no real magic to supporting ELK, but I would be not doing a good job of talking about observability if I talked about tracing and monitoring but not logging. And so obviously we plug into ELK. There's a kind of Ballerina log which is like syslog built into the language and can feed straight into there. So packages, I showed you a little bit of package management earlier with because I pulled a package from Ballerina Central. I'll just show you quickly. I think it'd be easier to go here and make a new directory, and we'll call it package. So if I do a Ballerina init, that's creating a package, and basically what that's done is to create a TOML file, which is saying, here's my it knows who I am, there's my organization name, and here's a version. And then what I want to do is to have some directory in there. So let's say H, and now I put code in there, and then I can build all that code into a package. And in fact, it's already created a bit of stuff there, so I'm going to get rid of that H, and I'm going to build. Actually, I want to build dot. Nope. I think let's just do what I was going to do. So let's make the hello, move hello service to hello, and sorry. Hello. So that's now created a package, and this is nice. It's basically looking for tests. So testing, again, is built in. There's a predefined test model, just like a sort of test package you would get in Node or Java. And it's now created a target directory for the executable. And let's just do push pull hello 0.0.1. And why is that in? What have I done wrong there? Okay. It looks like I haven't got my I need my credentials correctly set up for Ballerina Central, and it looks like I've got those wrong. So that's not going to work. So that's trying to do a whole clever thing to get me to log in. Let's see if I can find it. Has it? There we are. So I need to log into push modules. Let's see if this works. And okay, so that almost worked. It got me my credential, but I didn't. You have to define, if you want to push a module to Ballerina Central, you need to write a module MD file which describes it in Markdown, and I haven't done that. So, but you get the rough idea. Has anyone used gRPC here? No? Okay. So let me just continue with the slide deck, and I'll come back to that in a second. So we have packages, we have test, I mentioned. Obviously, this all fits very nicely into a continuous integration. So if you go look at the GitHub, so by the way, it's all open source. I should have mentioned that at the beginning. If you go look at the GitHub, we have, as well as those examples, we have a whole load of guides. So we have two things. We have Ballerina by example, which are just small examples. Ballerina by guides, which are larger use cases. Like this is an example of how to do messaging with ActiveMQ. And every one of these has got a Travis YAML and is auto-built by Travis. So every time they're updated or we update Ballerina, they all get built automatically. I have another example here, which is, does anyone use CodeFresh? No? So CodeFresh is a competitor to Travis and Circle CI and so forth. The reason I've used CodeFresh is that it has really nice support for Kubernetes, Docker Swarm, Helm, and Docker systems. So basically, if I go look at my Kubernetes services, what this is saying is that I've already configured this CI system to talk to my Kubernetes. And I basically set up a Kubernetes server in Google Cloud, and it's running on this endpoint, and it's running a app which basically does Hello World. So if I go to GitHub, so that, yeah, if I go to the code, here's that package, and here is the thing that's saying Hello World. I'm just going to go and be really dodgy and edit it directly in GitHub. Why not? I'm going to say Hello Budapest and commit those changes. And what that should do, if I go and look at my builds, is there's a pending build now in CodeFresh, because, in fact, it's a running build, because there's a GitHub hook between CodeFresh and GitHub. It's noticed that I've changed that, and now it's going to go through a set of processes. So it's going to clone the repo, it's going to build the service, it's going to run the tests, it's going to build the Docker image. It's going to push that Docker image, and it's going to deploy it to the GKE cluster. While it's doing that, I will just show you quickly. Let's just go to, sorry, I've lost it. Let's go and look at the CodeFresh YAML that does that. And basically, this fairly simple stuff. So it's doing build to do the build. It's going to do Ballerina test for the tests. The build image is basically that build automatically creates the Docker file. So then I'm just pointing it to the Docker file. Push image is some standard CodeFresh push, and then deploy it to the cluster. So let's see how that's getting on. And pretty well. We're pushing the image, deploying to the cluster. Give it a little moment longer. And hopefully now, if I go back to that live port, hello Budapest. So very nice integration with, I mean, obviously lots of systems can integrate nicely into CI systems, but I thought that was pretty simple and straightforward. Does anybody use OpenAPI or Swagger? Excellent. So this package I built, this demo, is basically defining a RESTful service. So I can just do Ballerina OpenAPI export demo.bal. No. Did I do that right? Okay. I messed up my BAL file. Looks all right. Love these. How do I get the right command? Okay. Something is, maybe I need to just annotate it a little bit more. So I annotated the resource config. Let's just add in a annotation on the whole load of bugs in here. What's going on? What have I got wrong here? This was all working, wasn't it? Sorry? Oh, I deleted something there, didn't I? It did have client config that. Nope, still masses of errors. Now I've done it. This is why you don't get your CTO to do live coding demos, because they always make mistakes. The only thing about the mistakes is, what I love is that there's always great programmers in there. There's like, people are like fixing my bugs, and you've never seen Ballerina before. I'm always like freaked out by that. Excellent. So now I've got rid of that, those problems. Basically, it's generated the YAML automatically from that. Now you can, if you want to add documentation and so forth, you can go and add further Open API service info, so I can go and add a whole bunch of attributes there, and it will put those into the Open API. But basically, very nice. So, how are we doing for time? I think we're probably going to. You guys have been very patient. This is quite a long session. Before I do any more, I'm just going to say, are there any questions? Because I think, you know, you've got a good flavor of Ballerina at this stage. But I've got a couple more things I can show you, but I think it'd be useful to see if there are any questions on it. Any thoughts?
I would recommend for questions to use Slido. How about that? Oh. The same app that we used for the main
that requires
stage.
Me to be all techie. Come on, there's only a few of us. Go on, just ask the question.
Whichever you
Let's
like
be old
to.
school.
Anyone wants the mic, maybe? Okay. Let's do it that way then.
Sorry,
Dina. It's okay. It's 10 people. We are a family here now. We're the Green 10 family.
Hello, my family. One of the common questions which I receive time by time is, what about performance of Ballerina?
It's a very good question. So the performance is patchy. So, for example, those simple HTTP request responses are very, very fast because although we haven't really spent much time optimizing Ballerina as a language yet, because it's got those network, we have all that network stuff built in, and we built that to start with. That is good. The problem, so there's really three evolutions of how we're building Ballerina. So the initial implementation, we built our own virtual machine called the BVM, the Ballerina Virtual Machine. It's built in Java, and so that balx file is compiled into a bytecode, and then we execute the bytecode. That is pretty fast for the kind of scenarios that are simple, like this demo. Like for example, if I just do a simple hello world and I call it on my 5-year-old laptop, I get around 20,000 requests a second. If I write that in Python on my laptop, I get about 600 requests a second. If I write in Spring Boot, I get about 20,000 requests a second. So it's about the same performance as Spring Boot. Pretty good. However, if I start doing like loops in Ballerina, if I do a for x equals 1 to a 10,000, that is not very fast because there's no bytecode optimization yet in the BVM. So that was our initial implementation, and we realized that there was a performance problem. So we've done we wrote that BVM in Java, and so we have a long-term plan to build something called Ballerina, which is a native Ballerina based on LLVM. And we expect the performance of that to be very, very good because we're going to generate high-performance native code. That is about a year away. We've started. So if you look at some of the Ballerina distros, there are some early LLVM code. But we realized that there were people who kind of didn't want to wait a year and didn't want to put up with the current performance. And so we've built a new version. It's actually, I was hoping to demo it today, but it's not quite there. It's about 2 weeks away from demoing stage. And what that does is generate Java jars. So it basically compiles into a jar file, and then you use Java to run that. And the performance of that seems to be 30 or 40 times faster than the current BVM. So we're pretty happy that that's going to get the performance up to a reasonable level. It's not going to be beating optimized Java. It's not going to be beating Go or Rust, but it's going to be in the same ballpark. It's going to be a lot faster than, say, Python. Okay?
Anyone else for a question? Okay.
Hello. So given that Ballerina has excellent API libraries integrated, do you think that I could use it, for example, to build a framework, testing framework for microservices. It seems like I could do
Yes.
something very lightweight, comparing to Java, for example.
So let me just show you the test code in this package. So when we do tests, of course, we are doing. So in fact, this is an auto-generated test. I have a. Let me just pull up Ballerina test. No, wrong thing. Let's just go to Ballerina by example and go find the test thing here. Testing assertions. There should be. I don't have a very good example here to hand, but you're right. It's basically really I've got some code somewhere, but I don't remember exactly where it is on hand. But there is, like, if you want to create an HTTP client, create a JSON, send it, super simple. So it is a very good language for writing tests in, yes. And there's all the assert and sort of stuff you'd expect to help you put it into a test package.
So now we have 2 more questions already. Can you go first? You haven't asked.
Sure. So it's connected to the previous question on performance. So when would you not choose Ballerina if you are implementing a service?
It's a good question. So I see, so I'm kind of biased. I like Ballerina. I think it's really fun. It's an enjoyable experience. I was talking to Edina earlier about, she was doing a session yesterday with a bunch of coders, girl coders, sort of teach girls to code. And she was trying to get them to look away from the screens, and she couldn't because they were having so much fun. And I think coding is an addictive thing for me when it goes well. I get into the zone and I go through these fast iterations, and it's you kind of get into the flow. And so I think Ballerina is very good for that. You saw here in this demo, in the first 20 minutes, I'd done 5 or 6 iterations of this code very, very simply. So I'm kind of biased, but, let me tell you what it was designed for. What it was designed for was to be the glue when you're connecting to lots of other services. Not necessarily the language in which you write the core business logic of those services. So if you're writing some complex logic, that is where, the OO nature of Python or Java, some of those things will help you. And there's a lot of frameworks and so forth. And then you can write those core services. Then you come to build something on top of them that's now calling into your customer database service, calling into your order processing service, calling Twilio to send a text message to someone. That is where Ballerina really shines. Now, over the long term, we have a kind of, we don't have a short-term vision for this. It takes a long time to get a programming language going. It took about 10 years for Go to really get a lot of popularity, and it had Google behind it. So it would be very hard for us to get anywhere near that. But over the long term, we want to make it a great language to build those core services as well. But that's not really been our focus yet. Does that sort of help you with that? The glue. Yeah.
Could you please explain what does it mean virtually register-based virtual machine?
Sorry, say it again?
Could you please explain what does it mean virtually register-based virtual machine? I understand the stack-based virtual machines and the register-based virtual machines, but what does it mean virtually set register-based?
So I can't explain that. I'm not involved in the implementation of the BVM.
All right.
So
can I have another question?
Yeah, have another question.
Ballerina.
So I can, if you, that's a good one to ask on Slido, and I will talk to my, to my deep programming language experts who built the VM, and we'll get you an answer.
All right. And then my other question is, Ballerina is a transactional language. But what does it mean? Is transactional because it has a transactional memory management, or is transactional because it supports transactions like database transactions?
So it actually supports transactions. It's a really good question. It's not something I was going to dive into, but let me find the example, because this is really nice stuff. So here we are. So it's still in the experimental features. So basically, let me just enlarge the font a little bit so you can see what's happening. So you can say, here's a transaction with 4 retries, and I'm going to do some updates to the database. And if it doesn't work, I'm going to abort. Otherwise, I'm going to commit that transaction. And if the thing fails, then I'm going to retry up to 4 times. So that's a local transaction. There is also a distributed transaction model. And this is really interesting because typically in a transaction model, what happens is you have a centralized transaction coordinator. So everybody comes in and they start doing their work, and then they go to the transaction coordinator on the network and say, I'm starting this work and I want to register it. Then everybody else says, okay, I'm a part of that work. They all carry on like this, and then eventually they say, I want to commit, and then they go to the central transaction register and say, I want to commit. That model really doesn't fit a microservices cloud native deployment, because you've got this central coordinator that's a single point of failure, all sorts of problems. So we built this really cool, lightweight model, and it's based on a model of transactions called infection. So basically, the first Ballerina server to get the transaction, to get the incoming HTTP request, says, I'm going to be the transaction coordinator for my work, and it infects the downstream work with the transaction. They call back, as part of that, it adds headers in. They call back to just that server that started it. So now, suppose that microservice dies. Basically, that transaction will die with it, and all the work will get undone because the transaction coordinator will go away. We'll start a new request, new transaction coordinator. On the other hand, the transactions are actually split amongst all the servers that are hosting that. So if you have 1,000 instances of your Docker container image running in Kubernetes, all 1,000 of those are going to have a partition of the transactions and are going to be the coordinator for part of them. Now, this is still experimental and early, but we think it's a pretty cool model for creating a much more microservice-friendly distributed transaction model. We also, it's not just for Ballerina, so we have a Java plugin which can infect Java work as well. So you can infect downstream Java work with the transaction. So you could, for example, have Ballerina coordinating a bunch of Spring Boot services.
Actually, we do have one question in Slido that has
cool.
been on for forever. Can you read it out, Michal, please? Because we have it since like the middle of your talk.
Since the middle of the talk, sorry, I should have.
Well, there was one question, but I think it was already answered. It was something about if it compiles or this virtual machine.
Okay.
But I'm from Slido, and if you are shy or you are want to stay anonymous, you can use the Slido. I already archived the question because I think it was answered. But you can use Slido.
I will log into
use
Slido
the green tent room
and make sure we're on here.
Yeah,
Just
also
so
the
if
speakers
anyone
get the Slido questions. So if you didn't get the answer what you were interested in, then you can ask it and Paul can get back to you. Is there anyone else who wants to say something now? Oh, you. Okay. Coming through. I don't really move like a ballerina, though. I cannot make that happen.
So, if I understood correctly, you can use Ballerina together with Java or other languages in the same framework. Is it possible? Because I'm thinking the the situation where probably I want to test both front end and back end, and I would probably use Ballerina for API testing, but I would use, let's say, Selenium, which does not have support for Ballerina for front end. So can I have them in the same frameworks? Do they like Java and Scala?
So up until now, no. Up until now, we've tried to maintain this separation. We said that if you want to call Java, you should call it over a network. You should call it via HTTP, gRPC, Rabbit, and so forth. However, the new JBallerina that I mentioned earlier that compiles into a jar file does make it very easy to call into Java. So there is a well-defined model for calling native code, an external code, and we kind of changed our mind on that. We felt, although it was a nice, we had this idea, this is a network programming language, so you should call Java by the network. But we realized that if we wanted it, that if we're going to build a jar file, we might as well let you call another jar file. So in about 2 weeks to a month's time, it's going to be very easy to like Scala and Java, or like Kotlin and Java, to call Java from Ballerina directly.
Well, thank you.
I'm afraid the only question on here is the one I don't know the answer to. All right.
Thank you, everyone, very much for participating. Paul, you especially, thank
Brilliant.
you so much.
Before we do this, can I just do 2 more slides? Because I was saving 2 slides. No, I thought we were done as well, but I was saving 2 slides because what I wanted to do was just say, how can you get involved? So can we have? So firstly, the language spec is still being developed. If you have input on that, please read it and define and add it. We have a Slack channel and a mailing list. Obviously, I tried to show you pushing a package. We nearly got there. It's really easy to build a package and push it into Ballerina Central. So, we have a whole bunch of connectors to GitHub, AWS, Twitter, Twilio, and so forth. But, there are thousands of things out there. And if you want to get involved and create a connector, that would be great. Obviously, if you have input on the spec or the implementation, just telling us that there's a problem with it is always brilliant because we want to know about it. And if you have deep compiler skills, then please, jump in and help out with the implementation. It's an open source project. So I just wanted to finish with that because I think, we'd love to get more people involved. We've been working with loads of partners. We've done work with Prometheus, Grafana, Honeycomb, CodeFresh. So we've been trying to build a community and get this integrated, but the more we can do that, the better. So that was my final words.
Thank you really so much. And thank you so much for participating. And this is just a little something.
Lovely.
It's a present of craftsmanship. And I need to say some very practical bits now as well. After really thanking Paul, and I think he has been speaking for so long, and it's so interesting. Even I was interested in it, and I told him earlier that I was literature major, so I will understand absolutely nothing of his talk. It was still very, very interesting. So, a round of applause for Paul, please.
Thank you.